This time I'm going to talk about what actually pays our bill and not all the free services. This slide Bruce mentioned already. So we have the community part of the company that promotes V6 and helps out the V6 community with Freedom 6 and so on. And then we have the part that actually pays the bill, and that's GogoWare and the products. And I'm going to talk a bit about the products and more about how you actually would use the products in your network. Right now, we're the only ones with an end-to-end solution. That is, we have the client side and we have the server side to deploy IPv6. There's a lot of work going on from the big vendors on the server side, but it's still, this is the only complete solution available. So we have the Gogo server, which is a tunnel server that does a variety of protocols, both to do IPv6 over IPv4 and to do IPv4 over IPv6. We have the gogo6, which is the home router for IPv6. And then we have the software client for the case you don't want to use a hardware client. So the gogo6 products, or the Gogo server especially, sits in between the IPv4 world and the IPv6 world in your network, and binds the two parts together. And the client side of it is what goes into your home, into your network as your enterprise network, and actually enables IPv6, or allows you to continue to run IPv4 if you're beyond the depletion. The gogo6 comes in a variety of flavors. The basic version is the most popular version right now, is to get IPv6 out in the network, enable your home network to run IPv6, which is the TSP version, or in some cases with L2TP support instead, which is intended to plug into a home network to enable IPv6 in that network. So it's pre-configured. You ship it out as an operator to your customer. You plug it into an existing network, and it connects to the best available tunnel server and provides you IPv6. This is to minimize the effort of an actual user to set up anything. That I think we mentioned before that the home router is an issue in getting IPv6 out there. It also comes in a DS Lite or dual stack Lite version, and DSTM, which is a managed version of DS Lite, which allows you to maintain IPv4 support in an IPv6 only network. So this is for the stage when you start rolling out new networks that are IPv6 only, but you need to maintain support for IPv4. And this is something you're going to have to maintain for a long, long time. But by putting it on top of your IPv6 infrastructure, you're at least making sure you're actually only running one network, which is your IPv6 network. And as v4 traffic is diminishing, you can continue using it, and IPv6 becomes the main part. It's like part of the migration process. There's also a 6RD version of the CPE to be used in cases when you need to connect one device. So if you have a computer that we can't install a software client, this is to allow you to run it on that kind of scenario. So as I mentioned, the TSP version, which is the IPv6 over IPv4 or IPv6 over UDP IPv4, is the version to roll out IPv6 in an existing network. The intention is to put it behind the home router. So you have your existing home network that's IPv4. You have your home router, and this goes in behind it and becomes your IPv6 home router, and bridges the access network of your operator to their backbone, which is probably today already IPv6. So it's just a matter of getting it from the backbone out to the end user. the benefit with this kind of solution is it works behind that. Many of the migration protocols require a public IP. This doesn't require a public IP, so it simplifies things quite a lot. People have talked a lot about dual stack through the days here, and we see it also as an important part in IPv6 migration or IPv6 deployment, because we need to somehow make it work together with IPv4. So the Gogo CPE comes in a DS Lite version, plugs in, oh, this is actually a bit in the opposite. Plugs in before your home router in that case. So it sits before your home router, your legacy home router, to make it continue run in IPv4. So it provides you the IPv4 connection in the case of your operator having IPv6 only. So either you have to have a home router that supports DS Lite, or you need something else to make it IPv4. So this is to support legacy equipment, more or less, in home networks. The nice thing with a protocol like DS Lite is that it's dynamic and stateless. So it's very low on resources when it comes on setting up the actual protocol. There's only when you're sending traffic that you're using resources. There are some negative parts of it as well, that it's lacking failure detection and such things, because there's no state in setup, so you lose out on that. The alternative is using a protocol like DSTM, which is the same type of encapsulation. We put IPv4 in IPv6 and send it out. Different is that we keep states for the tunnels. So we actually create a tunnel, and we make sure that that tunnel is actually working. This allows you also to assign static IPv4 addresses to certain users and so on. So in the case of having an enterprise user who wants an address, you can do that in that kind of scenario. So these two technologies mix fairly well. You could use one part for your unmanaged network, and you can use the other part for when you want to manage your customers more. So we support them all in the Gogo CPE. In addition to the hardware client, we also have a software client, which perhaps many of you have been using on Freenet 6. It's an open source client that can be integrated in different devices. Draytake is one example of a vendor that's been using it in their modems or home routers as an add-on to be able to allow their users to run it directly to services like Freenet 6. The client supports DSP, DSTM, and DS Lite. Currently, DS Lite and DSTM is only on the Windows version. To make all this work, though, you need the server end of it. We've been talking a lot about the client. The client, great, we need the client, but we also need the server end. And we do the server end as well. So the Gogo server is a tunnel server for terminating all types of tunnels, more or less. We have the TSP for V6 over V4. We have DS Lite and DSTM for IPv4 over IPv6. And we have 6RD for the case of IPv6 over IPv4 when you have a public IP available. It supports up to 50,000 users. Can do both types of tunneling at the same time, and so on. So it's a device for edge deployments, as we see it. Since the overall capacity is not that big, it's only 2 times 1 gigabit interfaces. So this is an edge deployment, part of how you want to manage your rollout traffic. Since your core is covered today, this goes into the edge. And that's what we're going to get into now. How are we going to do this? We have 2 different scenarios, more or less, as I see it. We have existing customers for a broadband operator. They have a V4 address today. It's already set up. It's working. The question is more, how do I get IPv6 out to them? So the choice is TSP or 6RD to IPv6. Then we had new customers. When you build a new network, you don't have any more IPv4 addresses, so what do? My view of it is you build an IPv6 only network and you put IPv4 on top. Because we know that IPv6 is going to continue to grow and IPv4 are going to stay or diminish over time. For this, we have protocols like Dual Stack Lite or DSTM to do it. Even though this is a migration we're talking about, and supporting legacy, legacy is something that's going to exist for a long, long time. Even though traffic volumes might be small in the end, support will be needed for a long, long time because you're going to have some obscure application or device or whatever it is that you need support. And as an ISP, you just have to have it. If you're an enterprise and you're running your network and you know what you got, fine. You can use this kind of migration path, you tunnel traffic and so on, but for the majority of it, you can just turn it off. You don't have to care because you know your environment. So you could use DS Lite or DSTM to provide IPv4 support for just a specific number of clients in your network. But the rest don't need it because you know they're not going to use anything that's related to IPv4. But for a service provider, a broadband service provider, you have to support it. You have no choice. So for deploying, it's a question of getting from the backbone over the access. The backbone is going to be dual stack because we're not wasting any address in the backbone. So running IPv4, not an issue. It's when we get to the edge when we start to waste addresses. And for IPv6, it's fairly easy to deploy. Most people have done it already. Protocols like 6P and such have made it fairly easy to upgrade your network to do IPv6, so it's already done. Now we have to make it all the way out. The different protocols have different pros and cons. There's been a lot of talk in standardization and so on standardizing one solution. I don't think there's one solution fits all. Networks are very different, and the different solutions fit different networks. 6RD, for example, is great if you manage the home routers and can push new software. It's a great solution to deploy. Like Free in France did with their managed modem, where they own the code to the modem, so they could add new code to the modem. They implemented 6RD, they pushed it out, they're done. Perfect. But for a lot of operators, that doesn't fit. You need a way of getting into the home. You need something that's more reliable than that because you don't have the address to use. So then you might go with something like TSP or perhaps even LTTP. The same is true in the reverse case. When you're going to do IPv4 over IPv6, there are pros and cons on the different protocols and what you can achieve and what you get out of them. So it's a matter of choice. What fits your network and your scenario. As I mentioned, the Gogo server is not intended to be a core product. It is an edge product. So it is optimized for that. It's intended to be distributed, multiple boxes as close to the customer as possible, rather than one big box concentrating all the traffic. What we think in terms of traffic is that deployment today of these kind of things are going to be a bit odd. Since if you start doing IPv6 only with IPv4 on top, your traffic on these kind of tunnel solutions are going to be maxed out in the beginning. And it's gradually start going down on IPv4. So the capacity you need for an IPv4 over IPv6 solution like DS Lite is going to be the maximum at the start. If you start adding more customers, you might be able to use the same boxes as you had in the beginning, like 5 years ago, because their traffic is going to be more and more IPv6. So the deployment is quite different in that sense. Your deployment is going to be instant from that perspective. You're going to put it in and you're going to use it. The reverse is true for IPv6. In the beginning, you won't be any traffic at all. You could put one box in the core and that's it. And you put all your 1 million customers on that box and you wouldn't see that much traffic still. But over time, that's going to change. So that is more like a normal deployment, perhaps. But the reverse is definitely true for IPv4 in that case. The deployment timeline is quite straightforward, according to me. I mean, there are different views depending on where you stand, and also depending on what kind of network you have. But in general, we have like the first step is all IPv4. That's where many people were. Step 2 is you start deploying in your core. I think that's where we are today. A lot of networks have it done already. Then step 3, or phase 2, is that you start doing trials. We see Comcast doing trials today. That's perhaps one of the earlier ones, so they're perhaps ahead of the curve. Then we hit the address exhaustion. Now suddenly we have to act a bit differently. We need to figure out how to continue doing business. And it's not a question of IPv6, it's a question of business continuity. So we might be starting with IPv6 only deployments for new networks, or using similar solutions to be able to preserve IPv4 addresses. And then we get to the end. So we're starting out with an all IPv4 network. And we upgrade the core. Okay, good. Now we have something to start with. We start doing some trials. So we add a Gogo server somewhere close to the core and tunnel it to some of the users to get our feet wet with IPv6 and see what happens when an actual user has IPv6. Now we hit the point where we're getting close to no more IPv4 addresses. So we build IPv6 only access network for our new customers and do a solution with IPv4 over IPv6, which is close to the edge because almost all traffic is still IPv4. And as traffic starts growing, we start adding more. This looks a bit odd. And in the end, we end up with a network where the majority of it is IPv6 only. I mean, the majority of new deployments is IPv6 only. And perhaps all the traffic is also IPv6 traffic, even for the old parts of the network, which now have been upgraded to support it. Because initially, I don't see a driver for many operators to add IPv6 support to existing networks. It's more likely that you start using IPv6 as a tool to continue doing business. So that's my take on how a deployment would look. Thank you. Questions?
So the 6RD Go servers are all specifically, can you use a third-party 6RD client or is it strictly restricted to Gogo?
No, any 6RD is compatible. Yes. Yes, you can. It's fully compatible with the 6RD and DS Lite and TSP servers. Okay, thank you.